So we're going to start by finishing up on A4. And A4 is on complex numbers. And what are the two operations that we learned how to do yesterday with complex numbers? Add and subtract. You might have already known it from Algebra 2, but we reviewed it. Now, we talked a lot about I. And I told you that I is equal to something. Can't explain why it's equal to that. This is what it is equal to. Does anybody remember what I said I is? Yep.
Square root of -1.
Yep, square root of -1. So then, based on that, we were able to define what I squared is. Does anyone remember what we said for I squared? -1. And that's important, that I squared equals -1. Because if you leave I squared in your final answer, I can tell you right now it's wrong. Because you didn't simplify. So anytime that I squared comes up in a final answer, change it to a -1. Now, when we add and subtract, I squared does not come up. When you multiply and divide, it does. Okay, so any questions about I squared being in the final answer? Shouldn't be in the final answer. I think, if I remember, we're going to start off with a multiplication problem right after this. Yep, got it. So here's two complex numbers. A, B, C, and D are all going to be values that are given to you in the problem. We're going to have to multiply them together. We're going to have two sets of parentheses multiplied together. If you didn't have complex numbers, if you had something like this from Algebra 1, does anybody remember how you multiply those two things together?
Yeah.
How do you do it?
Pretty sure you take the first term.
Yep.
And then you will multiply that by x2.
Yeah, so you multiply the first term times x.
And then you'll take it again and multiply by y2.
What is that in this case?
-4.
Yeah, so you're going to multiply first terms, the outer terms, yep,
And then you can do that
with 3 and
the first term.
first terms. Those are called the inner terms, and then
The outer term.
the outer terms. So that's the distributive property twice. Some people remember that as FOIL, but that's how you have to multiply complex numbers. Okay? Same thing's going to happen. So you end up distributing the A to both parts of the second number, and then you distribute the BI to both parts of the second number. Yeah? Good question. Which one of these is going to result in getting an I squared? You're doing four multiplications. The BI times the DI. That's what's going to give you the I squared. So anytime we deal with those last terms, we're going to have to deal with that I squared. Okay, so if you remember it as FOIL, first, outer, inner, last, you can think of it that way. Or it's really just the distributive property twice. That's what it is. Okay, does everybody have that? Let's try an example. So we're going to multiply 2 plus I and 1 minus I. We'll just go through it step by step. Dominic, what are the first two things you're going to multiply together?
2.
Yep. So we got 2 times 1, which is going to give me how much? 2. 2. Okay. Austin, what are the next two things I'm going to multiply together?
I.
2 and what are my outer terms?
I'm not quite sure.
Anyone help them out? What are the outer terms in this case? Yeah.
2 in the eye.
The 2 and the what?
Negative I.
Negative I. So we're going to multiply 2 and negative I. And Alex, what's 2 times negative I?
Negative 2I.
There's not much we can do with that. It's just negative 2I. Okay, so we've distributed the 2 to everything. Now we have to distribute the I to everything. Grady, what do I multiply the I by first?
1.
Okay. I times 1 is going to give me
1.
just 1 I. You can put 1 I or you can just put I. Same. Sam, what about the last 2 terms? Let's break it down. First of all, it's a positive times a negative. What's a positive times a negative?
Negative.
So we're going to start with a negative. And what's I times I?
I squared.
I squared. So positive I times negative I is negative I squared. All right, now we've got some like terms we want to combine, and we have to fix something that I said not to leave in the final answer. All right. Fiorella, do you see the like terms we can combine?
The i's, so minus 2i plus 5.
And what's minus 2i plus 1i?
1i. I mean, negative I.
Yeah. So negative 1i minus, and now we have an I squared. What did we say earlier? I squared always turns into negative 1. So this negative is coming from the formula. This negative inside the parentheses is coming from I squared. Okay, so now we've got 2 minus I minus minus 1. When you have 1 minus a minus, what does that turn into? Turns into a plus. And some of these steps we can kind of do in our head. We're really writing each one of them down. But we might do a couple in our head next time. Now combine your like terms again. Jenna, what's 2 plus 1 give me? 3. So that is the final answer. The real part's 3. Imaginary part, negative 1i. Questions on that one? Right, let's try one more of those, and then I think we'll finish up with division. Yeah. Okay, so let's start with multiplying again. Ryan, first 2 things I multiply?
8 in the eye. 8 in the 3.
Yeah, eventually you got to multiply 8 and 9, but if we want to do the same order as last time, let's stick with the 8 and the 3. So that's 24. Abigail, the next 2. Multiplying those 2 complex numbers together.
8i.
Yep, so the next ones we're going to do is 8i. So we've distributed the 8 to everything. Nyasia, what are the next 2 we're going to multiply? I and 3, and that gives me how much? 3i. And Tyler, what are the last 2 I have to multiply?
The I and the other I. I squared.
So positive I and positive I. First of all, it's a positive times a positive. So it's positive. And you said it's positive what? I squared. Okay, we've got some like terms. So first thing we'll do is combine those. Dustin, what do I get when I combine 8i? 11i. And Jackson, what's going to happen with I squared?
We make that negative 1.
We're going to make that negative 1. Okay, so now we've got that. Yeah. Okay, so we changed I squared to -1, which then allows you to combine like terms one more time. So Dominic, my final answer for this one, simplified as much as I can.
23.
Yep. 23 plus 11. Question on that? So multiplying is really important because when we get to doing division, the way you have to do division with these kind of numbers is you have to multiply. So if you can't multiply, division is going to be a bit of an issue. When we divide, something's going to come up called a conjugate. So we're going to talk about what is a conjugate. So let's say that we had a complex number, a plus bi, and I'm going to call that complex number z. So z is the name I'm giving. Z is the letter they use a lot of times when you have to name a complex number. If you take z and you put a bar over it, pronounced z bar, this symbol, probably something you haven't seen a lot before, but this means something special. When you put a bar on top of a letter like that, that's called the conjugate. That symbol means conjugate. And the conjugate, it's a very, very simple idea. All that the conjugate means is to take whatever symbol you had between the real part and the imaginary part, and you make it the opposite. So if it was a positive, you make it a negative. If it was already a negative, you make it a positive. So what you're really doing is you're changing the sign of the imaginary part. You do not do anything to the real part. Keep that the same. Okay, conjugate is when you change the sign of the imaginary part. And a shorter way to say change the sign of is just to say that word, negate. Negate means the opposite of. Find the conjugate of a complex number, change the sign of, or just say negate the imaginary part. So before we use the conjugate to do anything, we'll just practice a couple of examples where we find it. So I'm going to give you a table, and on the left I'm going to put a complex number. And on the right, I just want to know what the conjugate of that number would be. Bless you. Okay, so 3 plus 4i. What do you think the conjugate of 3 plus 4i would be?
Would it just be minus? 3 minus 4i.
3 minus 4i, yeah. These are what we call conjugates. And when you multiply them together, because they're almost the same thing, except one's positive and one's negative in the middle, something happens. What happens, you'll see in a minute. How about that one? Negative 8 minus 2i. Negative 8 plus 2i. Okay, so remember, just change the sign of the imaginary part and leave the real part alone. So negative 8 plus 2i. How about 5i? Would just be negative 5i. Yep. If you're confused because there's no real part there, think of it like this. Pretend there's a 0. Well, that's 0 plus 5i. The conjugate is 0 minus 5i. Okay, but you're not going to see the 0 if it's a 0, they don't write it. How about 3?
Negative
No,
Just 3.
just 3. Yeah. Because this, if you think of 3 as a complex number, there it is. It's 3 plus 0i. The conjugate would be 3 minus 0i. Well, because the imaginary part is 0, whether you add it or subtract it, it doesn't make a difference. So it's the same. So any questions on how to find the conjugate of a number? Okay, so what happens? I said something happens when you multiply two numbers that are conjugates together. Let's see what happens. So this problem is saying to multiply whatever number they give you and its conjugate. Here's the number that they're giving. 3 minus 4i. Multiply by the conjugate. So what am I going to put next to it? 3 plus 4i. I can already tell you, when we multiply all that out, we're going to get 25. It's not because I just memorized the answer. It's because I can look at that, and there's a trick to doing a problem like this very quickly. Because these are conjugates, and only because they're conjugates. Let's just FOIL it out the long way, and we'll see what happens. Okay, what's 3 times 3? 9. Don't forget the answer I said. Just keep that in the back of your head. So 3 times 3 is 9. What's 3 times 4i?
12i.
That's 12i.
Well, that means negative 12i.
That's negative 12i. So, well, we'll come back to that. Then we have a negative times a positive. So negative times positive gives me
16i squared.
So yeah, start with the negative, and then we're going to have 16i squared. Okay, what happens there?
Becomes 16.
Okay, so we're going to deal with the I squared. How about before that?
Your eyes cancel out.
The i's cancel out. That's one reason I could do this quickly in my head, is because I didn't really even have to multiply the outer and the inner, because I knew they were going to disappear. That always happens with conjugates. So these are gone. So now I have 9 minus 16 times I squared. But what's I squared? Negative 1. Now we've got 9 minus, what's 16 times negative 1?
25. Wait, no, 16.
16 times negative 1 is,
16. Oh, negative 16.
yeah, negative 16. And then because we have 9 minus 16, that's how we get 25. And that's what I told you the answer would be. So the shortcut, all you have to do is look at that number and look at that number. If you take the first number I circled and square it, what does 3 squared give you? 9. If you take the second number I circled and square it, what do you get? 16. And then you add them together. So that trick only works if you're multiplying conjugates, but it is a trick I'll use going forward because it saves a little time. Okay, let's try another one. This time I don't want to FOIL this out. Remember, all you have to do, because those are conjugates, is take one number, square it, take the other number, square it, and add them up. The I completely disappears when you multiply conjugates. That's kind of important. The I goes away. Okay. So what's the first number that you would square here? Five. What's the second number you would square? 4. And what do we do with those two numbers? Add them together. So what's 25 plus 16? 41. Yep. If you don't want to use that trick or it's confusing, that's fine. Then FOIL it out every single time. But that's what's going to end up happening. It's just going to take you more steps to get So 41. And notice again, the original problem started with i's. The final answer has no I. No I at all. So why is it important we have answers without i's in them? Well, because you don't write it yet, because I'm going to show you how to do this. When you have a division problem, the only rule about dividing complex numbers you got to be careful about is you cannot leave an I in the bottom. Just like you can't leave square roots in the bottom. So what we're going to have to do is multiply by something that would get rid of this I. Well, we just learned that if you multiply by a conjugate, all the i's will disappear. So that's what you have to use when you do division. Multiply by a conjugate, it's going to make the I go away. And that's the only thing that we use the conjugate for. Okay, so how do we do that? So in order to divide two complex numbers, it's really going to be a multiplication problem. It's not really going to be a division problem. And in order to divide two complex numbers, you're going to multiply the top and the bottom of the problem they give you by the conjugate of what's in the bottom. Multiply the top and the bottom of your problem by the conjugate of what's in the bottom. So we'll try two examples of dividing complex numbers, and then that'll finish A4. Now the first division problem we're going to do is a little bit easier. The bottom has a real part and an imaginary part, but the top only has a real part. That's going to make it a little easier to do the top. In the second one, both the top and the bottom have a real and imaginary part. That makes it involve a little bit more multiplication. Okay, so to divide these, remember, big idea, you cannot leave an I in the bottom. So what could you multiply the top and the bottom by so the I disappears from the bottom? Yeah, Alex?
3 minus 4i.
3 minus 4i. I don't care if there's an I in the top. In fact, there will be. That's fine. We just don't want to leave it in the bottom. Now, 3 plus 4i and 3 minus 4i. We've got to FOIL these two together in the bottom. But remember, those are conjugates that we just learned a trick. In fact, I think we did that exact problem. What did we get when we did 3 plus 4i times 3 minus 4i? 25. Now, in the top, there really isn't any trick. You just need to do it out. But because this is a 1, what happens when you take the 1 and you distribute it out? Yeah, this doesn't really change it. So not only is the top an easier version of the distributive property, because you only have to multiply two things, you're multiplying by something that doesn't even change the problem. So it ends up staying as 3 minus 4i. Now, that's almost the final answer, but you can't leave it like that. When you write a complex number, it has to be written like this. Real part, plus or minus, an imaginary part. You can't have one big fraction. That's not standard form. So the way we figure out what goes in each of these boxes is you're going to take each one of those numbers and put them over 25 separate. So the real part is 3/25, and the imaginary part is negative 4/25. And usually they put the I right in the middle, like that. If you put the I in the top, you're not wrong. You can put it in the top. But it's kind of like when you do like y equals mx plus b. If you have to put the variable next to the slope, they usually put it right in the middle, like that. There's nothing wrong with doing it like this. You just don't usually see it that way. Okay, so the real part is 3/25, and the imaginary part is negative 4/25. And that's how you divide. Any question on that one? That's how you have to leave your answer, yep. I mean, if you left it like this top one, I'd probably take off like a point or two, because I could see, like, if it was a short answer question, when you type that in, I could tell you pretty much got the whole thing. You just didn't write it in standard form. Okay, let's look at this one. All right, so we want to divide them, and we can't leave that I in the bottom. So what are we going to multiply the top and the bottom by? So the I goes away in the bottom. Yep. 5 plus 12I. And remember, you can't just do it in the bottom. You gotta do it both spots. You gotta do it in the top. So the bottom, we're multiplying conjugates. So let's use the trick to handle that one quick. We're going to square two numbers and add them together. That's all we have to do. What's the first number that I'm going to square? 5. And what's the second number? 12, which gives me? 144. So the bottom is going to end up being 169. Now the top, we do not have any trick to speed that up. We just got to go through all the multiplications. Okay, so Austin, if I'm going to multiply these top two together, what are the first two things I multiply?
1 and 5.
1 and 5.
And 1 and 12I.
Okay, let's write those down. What's 1 times 5 give me? 5. 5.
And then 12I.
And then I'm going to put that off to the side for a second. So 1 times 12i is 12i. What about 20i? And Curtis, when I combine those like terms together, my 12i and my 20i, how many i's does that give me? 32i. Okay, good. And then Cameron, my last one, it's a positive times a positive. So let's just start with that. What's positive times positive? So we're going to get a positive. And what's 4i times 12i? 4i times 12 would be 48i. But what's 4i times 12i? Something happens here that we have to take care of. I said, don't ever leave this in your final answer. Do you remember?
Oh, it would be 48i squared.
Right. You got 4i times 12i, so that's 48i squared. Okay, so now we've multiplied it out. We're just going to combine all the like terms and get that in standard. Well, we just said that's going to be 169. And what about what I just circled? 48i squared. That's really what number?
Negative 48.
That's a negative 48. So if we just write it above it, we don't have to rewrite the whole problem just to do that one step. Now we've got some like terms we can combine again. 5 minus 48. What's 5 minus 48?
Negative 43.
It's negative 43. Positive 32i. And we're just about at the final answer, but what do I have to do with that?
Split each side up over another.
Right. Instead of one big fraction, we're going to split it into two. So standard form, this is your final answer. Negative 43 over 169 plus 32 over 169. Notice I'm not using any decimals. We generally don't. Right? We don't divide 32 by 169 ever and round that off. I mean, if it was 32 divided by 64, then I would reduce it. Like that'd be 1/2. But other than reducing a fraction, you just leave it the way it is. Okay. Questions on division? All right. So 5.1, we looked at polar coordinates. A4, we looked at complex numbers. Now 5.3 connects the two. So now we're going to take complex numbers and the idea of polar coordinates and put them together. Okay, so 5.3, this will be our last section. We will not finish it today. We'll finish it tomorrow. 5.3 is called the complex plane. There's more in it than just that. That's the title in your book. So the idea of a complex plane is to basically take a number like this, 5 minus 12i, and find a spot for it on this graph. Where would it go? And the way we can figure out where it goes is we use a two-axis system, but we don't call them the x and the y-axis. When we're talking about a complex plane, we call them the real axis and the imaginary axis. So if you want to graph a complex number, all you have to do is look at the real part of your number, figure out what it is. If the real part is positive, you move right. If it's negative, you move left. Then you look at the imaginary part of your number. If it's positive, you go up. If it's negative, you go down. So graphing 2 plus 3i is exactly the same as graphing this. If you can graph 2, 3, you can graph 2 plus 3i. Okay, so let's graph. Sam, what's the real part of 2 plus 3i? 2. So we're going to go right 2. And Grady, what's the imaginary part? Just what number? 3. Positive 2 is the real. Positive 3 is the imaginary. So go to 2 on the real and go to 3 on the imaginary. And that's how you graph the point 2 plus 3i. That's it. What's really important about that point is the quadrant. Because when we do the last thing we're going to do today, we're going to have to know the quadrant of this point. So that's quadrant 1. Okay. How about 4 minus 8i? Can anyone explain to me, starting from the origin, how do I get to 4 minus 8i? Yep.
Go right 4 down 8.
Right 4. So the real part is 4, so you're going to go to 4 on the real, and you're going to go to negative 8 on the imaginary. So 4, 1, 2, 3, 4, 5, 6, 7. There you go. So that's 4 negative 8, 4 minus 8i. Do you think it's okay to switch the two numbers, like in a coordinate? Would you end up at the same spot all of the time? No. If you were graphing like 2, 2 and you switch them, then yeah, you would. But you can't switch them. That's a mistake some people make on the test. They flip the real and imaginary. Real is horizontal, imaginary is vertical. I think they're even labeled on the grid on the test with an R and an I. So follow what it says. How about negative 8? How would we, Fiorella, how would you graph that one?
Just go left 8.
Yeah, go left 8. Think of it as negative 8 plus 0i. There's no imaginary part to that one. So that's not in a quadrant. That's on an axis. Right? And how about 5i? Oh, you got that, yep.
Would it be up 5?
Up 5. Think of it as 0 plus 5i. No real part, so you don't go left and right. But the imaginary part is 5. So the way that'll work on the test is you'll have a grid. You just click where you want to put the point. If you put it in the wrong spot, you can just drag it somewhere else. So any questions on graphing those points? All right. So now, the last thing we're going to look at is combining the idea of what we did on Monday and what we did yesterday. We're going to take complex numbers now, and we're going to write them in polar. What form do we call this? If you put the real part first, and then the imaginary part second. Anyone remember what I said you call it? It's what? So not a conjugate. We're not going to change the sign of anything and multiply. There's just a name when you write a complex number like this. I know I'm putting the I before the Y. I'll tell you why after. But there's a name for this. Yep. That's called standard form. Okay? You can call it standard form or rectangular form. It's the same thing. Now you might say, well, wait a minute, it looks a little bit different. Normally we don't put I2. We put 2I. So why did I put the I before the Y? Well, the formula we're going to write down in the book, they put the I before the Y. It doesn't really matter. You can put it before or after. I'm just trying to make what I do match what's in the book. And I know that I normally use A and B for the real part and imaginary part, but we have to kind of visualize this. And I think for most people, if I use X and Y, you'll probably connect that more with X being horizontal and Y being vertical than you would if I use an A and a B. Okay, so X is left and right movement. That's the real. Y is the up and down. That's the imaginary. When we write it in polar, like we learned about on Monday, you do not have an X and a Y in polar. What two letters do you have instead?
R and theta.
You have an R and a theta. So we have to get rid of that and that. Cannot have an X and a Y. And we had formulas. We don't even have to figure them out again. We already have two formulas that convert X to polar and Y to polar. We did those on Monday. Does anybody remember from Monday? We wrote X equals, then we had a formula. It's the formula we had to find X. This would be under converting polar to rectangular.
It would be the number, cos, degrees.
And what did we call the number? We used the letter for that. The what? Yep, R cosine theta. And we proved where that came from on Monday. And what did we have for Y? Okay. So those are the two formulas for Monday. We're going to reuse them right now. Instead of putting an X, we're going to replace X with R cosine theta. And instead of putting Y, you're going to replace that with R sine theta. So you want to make those two exact changes and then write it down. And that's the trig form of a complex number. or trig form or polar form. You might hear me say it both ways. It's the same. Okay, so what are we going to change x to? R cosine theta. Don't do anything with the plus sign. Don't do anything with the I. And what are we going to change y to? R sine theta. That is how you write a complex number in trig form. Now, if you look at it though, look at this and look at that. What do they both have in common as a factor? They have well, the degree, that's your argument. So yeah, they have the same argument, but they have the r in common as a factor. Well, whenever two things have the same factor in common, you can factor that out. So the way we write, as simplified as possible, is we take the r, because they both have it in common, and we pull that out in front. And we end up with cosine theta plus I sine theta. If you distribute this r back out, we'll go right back to what we had. But that's called the polar form of a complex number. So to write a complex number in polar form, it requires you to know two things. Just like polar form without complex numbers requires you to know. What are the two things that you need to know? The radius and the angle. Okay, we have to know those two things. Well, how do you find the radius and the angle? That's what we learned yesterday. You use the exact same formulas. R was the Pythagorean theorem, and theta was the inverse tangent of y over x. If you were in what two quadrants? 1 and 4. What if your angle was in quadrants 2 or 3, where you have to add to the inverse tangent of y over x? You have to add 180. So all the formulas that we know are the same. We don't have to do anything different. What's going to look a little bit different is the final answer. That's how the final answer looks. Okay, I'm just making these numbers up. That is an example of a final answer. You don't do anything with that. You don't write it yet. You just leave it like that. The 3 and the 15, I just picked those numbers randomly. If you said, well, shouldn't I do out the cosine of 15 and then multiply the 3 out and then do the sine of 15 and multiply the 3 out? If you do it out, you're going to be taking polar form and changing it back to what you started with. So if you want to check your answer, fine, then do it out. But what I'm looking for is this. That's the final answer to the problem. Let's one of those to try, and that's it. Okay, so root 3 minus I. Now, you look at that at first, and you're like, oh, it's got a square root in it. But what did I say earlier when we did this in the homework? When you have a problem with a square root of 3, what usually happens? It works out nice. So it might look like it's not a nice problem, but it is going to come out nice. Now, there's no number in front of the I that's written, but what number is always understood to be there? 1. The 1. If you want to put the 1 in, because it helps you to think of what the imaginary part is better, it's negative 1, you can put the 1. Okay. So, what's one of the two things we have to find? Okay, so let's figure out what quadrant it's in, because then that's going to control, do we use inverse tangent y over x or 180 plus inverse tangent to get this angle? Okay, positive, negative. I don't care really to scale. But yeah, right and down. So you're going to be right about there. So we know we're in quadrant 4. You went right square root of 3, and you went down. Okay, what's my formula to find theta if I'm in quadrant 4? 1 and 4 is.
The what's tangent y over x.
Can you say that again?
180 is tangent. Oh no, it's just tangent.
Just the inverse tangent of y over x. And which number here is y and which number here is x? If you get confused, just look back up at where the x and the y are.
We have 1 over square root of
Yeah, the number next to the I, that's the y. And the number that's the real part, that's the x. Okay, so we need an inverse tangent of -1 over square root of 3. Second inverse tangent, -1 divided by square root of 3. Okay, I got -30. The problem doesn't say you can't have a negative answer, then leave the negative answer. But if they said write it positive, what can you add to -30 to make it positive? You can add 360, which would come out to 330. Okay, so there's your angle. That's what's going to go in the 2 spots where the angle is. Okay, one more thing I need.
Yeah.
I need my R. What formula is this really based on that we use to find R? Yep, it's a Pythagorean theorem. You're solving for R right there. Okay, so I'll start it off with R squared, and what's going to go on the other side?
3 plus 1.
So I'm just going to write it square root of 3 squared plus 1 squared, which does turn into what we just said. 3 plus 1. So R squared is 4, which means R is how much? 2. Okay, now just put that together and write your final answer. Take the R that we got and take the theta that we got and fill them in those spots. There's 3 spots to fill things in, and then stop. Leave it just like that. So R cosine theta plus I sine theta. So R cosine theta plus I sine theta. That's the final answer. Okay. As I said before, if you take this 2 and you distribute it to cosine 330, you're going to get square root of 3. If you take the 2, well, let's just try it. Take the 2 and distribute it to the sine of 330. Watch what you get. 2 sine 330. I got -1. -1. That's what I started with. So if you distribute it out, you're going to change the answer back to what you started with. So that's why we stop right there. Okay. Any questions on that? Okay, so tomorrow we're going to look at what's the whole point of writing a complex number in trig form. Why we already can write it the way we've been writing it. Why bother with this stuff? Well, you know how we just went through multiplying and you had to FOIL things and then use conjugates and get all the I squareds, change them to -1. If you write complex numbers like this instead of the way we've been writing them before this, all that stuff goes away. You don't have to deal with conjugates, I squareds, or anything. So it makes multiplying and dividing complex numbers a lot easier. And that's what we'll see tomorrow. Okay, so 560, that's the end of A4 in the back. And page 333, that's 523.